If D equal to A1, A2, A3, first column, B1, B2, B3, second column, C1, C2, C3 is not equal to 0, there is a unique solution given by x equal to D1 upon D, y equal to D2 upon D, and z equal to D3 upon D. The explanation for this is D1 equal to D1, D2, D3, first column, B1, B2, B3, second column, C1, C2, C3 in the third column. Substituting the values of D1, D2, D3, we get the first column as A1x plus B1y plus C1z, A2x plus B2y plus C2z, A3x plus B3y plus C3z as the first column, B1, B2, B3 as the second column, C1, C2, C3 as the third column. Now operate. C1 goes to C1 minus y times C2 minus z times C3. We get D1 equal to A1x, A2x, A3x as the elements of the first column, B1, B2, B3 and C1, C2, C3 as the third column. Pulling out x common from the first column, we get x times A1, A2, A3, first column, B1, B2, B3 as the second column, C1, C2, C3 as the third column, which is equal to x times D. Therefore, x is equal to D1 upon D. Similarly, y is equal to D2 upon D and z equal to D3 upon D, which is a unique solution where we have assumed D is not 0. Now we have the following algorithm for the condition for consistency of the solution of a set of equations. First condition is when D1 square plus D2 square plus D3 square is not 0. That means all D1, D2, D3 are not zeros. In that case, we take two conditions, two cases. When D is not 0, there is a unique solution, x equal to D1 upon D, y is equal to D2 upon D, z is equal to D3 upon D. In this case, we call it the solution is consistent, the equations are consistent. The second case is when D is equal to 0, two cases arise. When D2, D3, D1 are all zeros, then there are infinite number of solutions, but still the equations are consistent. And the second case is when D1, D2, D3 are not all zeros, then we say there is no solution and the equations are inconsistent. Now the second case is when all D's on the right side, D1 is 0, D2 is 0, D3 is 0. In this case, the equations are said to be homogeneous. We call them homogeneous equations. Two cases arise when D is not 0 and when D is equal to 0. When D is not 0, then we have only one solution, that is x equal to y equal to z equal to 0. We call it a zero solution or a trivial solution, and the equations are consistent. And the second case is when D is equal to 0. In this case, it has infinite number of solutions, and again the equations are consistent. This tells us the methodology of finding the consistency of the equations. The solution for the equations 2x plus 3y equal to 7, 4x plus y equal to 4 is A 2 comma 1, second 1 upon 2 comma 1, third 1 upon 2 comma 2, and last none of these. Now we use Cramer's rule here. For 2x plus 3y equal to 7, 4x plus y equal to 4. D is equal to the determinant form by 2, 4, 3, 1, which is equal to 2 minus 12 equal to minus 10. D1 equal to 7, 4, 3, 1, which is equal to 7 minus 12 equal to minus 5. D2 equal to 2, 4, first column, and 7, 4 in the second column, which is equal to 8 minus 28 equal to minus 20. Therefore, x is equal to d1 upon d equal to minus 5 upon minus 10 equal to 1 upon 2. Y is equal to t2 upon d, that is minus 20 upon minus 10, which is 2. Hence 1 upon 2, 2 is the solution. Hence C option is correct.